Hello students. Next we move on to the program status register instructions. In short, it is called as the PSR instructions. So mainly we have two instructions here. One is the MRS instruction, another one is the MSR instruction. Here MRS instruction nothing but transferring or moving the contents of the CPSR or the SPSR to a register, which means we are doing a read operation. And here MSR is actually nothing but moving the contents of a register into the CPSR or SPSR, which is nothing but a write operation. So this one is read and this one is a write operation. So we can perform this by using MRS and MSR respectively. Now we'll just go to this particular diagram, okay, which we'll just recall here in a jiffy. Okay, now we know that the CPSR or the SPSR, generally called as the program status register, divided into four fields: the control field, extension field, status field, and the flag field. Now moving on to the flag field, we have studied mainly four flags: the negative flag, the zero flag, the carry flag, and the overflow flag. And moving status and extension, we haven't dealt with it. Okay, and moving to control, the first 5 bits, that is 0 to 4, is reserved for mode. We have 7 modes, and this is the thumb mode. If it is active, it's 1. Okay, and this fast and interrupt, there are two types of interrupt: the fast interrupt and the lower priority interrupt. So they are called as the mask fields, which means if this is 1, the interrupt is masked or disabled. Okay, so now mainly we are going to study the syntax of the MSR and MRS instructions. So MRS, as I had already said, that it is the read. It's nothing but reading the value from the CPSR. Okay, so we have only one syntax. For write operation we have two syntaxes. That is because we can either write with the help of a direct value, immediate value, or indirectly by the usage of a register. Let's take an example here. Now you see the before execution case. You can see here only the I bit, the lower priority interrupt, is disabled here. Okay, that means it is masked. That's why you can see that it's capital, it's equal to 1. And we are in the supervisory mode. We are using MRS instruction first, means read operation. We are copying the contents of CPSR onto R1. Now we are going to change R1 by the help of BIC. BIC is nothing but logical instruction, stands for logical bit clear. So what it does is, it's nothing but we'll use the help of a text box to explain this concept here. Okay, let's bring in one. Okay, so BIC nothing but stands for logical bit clear, right? Or nothing but what it does is, we do an AND. First we do a NOT operation, followed by an AND operation. Right, so we'll see that with the data is here 80, which is expanded in binary. Only the first from the right, only the 8 bits are considered. Okay, so here only the 2 digits, so I'm going to write that. So we are going to NOT this value first, so that is nothing but 1000 and then 0000. Okay, after NOTing, what will we get? We will get the value as 0. Okay, so this is the value we get after NOTing. Once we finish NOTing, we are going to AND this content with the contents of the CPSR. Again, we are going to only take this bits, the rightmost 8 bits. Okay, so not I don't know what will be the bit representation of supervisor. You can refer that. So I'm just interested in the first 3 bits. Okay, the first three bits nothing but stands for I is equal to 1, F is equal to 0, thumb is equal to 0, and the rest 5 bits is nothing but our supervisory modes. Okay, so I'm not going to write that 5 bits, 5 plus 3 8. Now you just take this as a dummy bits. Okay, all are ones, which is when we AND it, all are going to be passed except this 0 is going to be ANDed with 1, which will give you what? Which will give you nothing but 0 itself, and rest of them will be all ones itself. Okay, whatever it is. Okay, now so which means that we have actually disabled the I bit. We have removed the mask. Okay, you can see that post execution, that is post execution, the I value has become smaller, right, as compared. So what we are going to do after manipulating the register R1 is we are going to do write operation now with the help of MSR instruction. So we are going to copy the contents of R1 to CPSR, and you can see the result after execution.